Welcome and hello. This is a lesson in WRIMS. And in this lesson, I'm going to be talking about executing the model, running the simulation, and viewing the results. And then after that, we're going to modify a few input parameters, run the model a couple more times, and then see how those results change. All right, so what I have on the screen here is the WRIMS user interface. I went ahead and added a project already, L8 here for our lesson 8. Model execution and results. This particular model we're ready to run and have actually been building up over the past few lessons. 5, 6, and 7 have all been adding up and leading to this model build. So for a quick reminder, if you haven't watched those lessons, that's not a problem. Here is the schematic of our model. We have an inflow variable, I1. This is a state variable. We know the inflows. This is going to be a 1-year simulation with a 1-month time step. So the flow enters this node 1, we'll call them nodes. Nodes are junctions, and then it continues flowing down to node 2, and then down to node 3, and then out. That is river A. At this node 2, there is also a diversion over to a farm. The farm demand is also a state variable. We know that what that demand is. And the decision variables is the flow through the channel C12 through the channel C23, that's the two segments of river A, and then the flow through the diversion, which is called D24. So you see the three variable names right here. Those are the three decision variables. Like I said, the inflow and the demand, we know those. Those are state variables. The next slide here actually adds those values. So we're going to have a constant 12 CFS inflow for the entire year. And then the demand is also going to be 5 CFS, which I'll put right there. Therefore, when we run this model, we should expect 12 CFS to flow through this segment C12, channel 1-2, and then 5 to be diverted, and then 7 to continue downstream, just based on the demand and our constraints of continuity and non-negativity. And we also said that the diversion flow cannot exceed the demand. So that's what we're expecting to see. If we go back to WRIMS and then open up the DSS file, we have a sv.dss file. This is where we have our inflow and our demand time series data. And then the dv.dss file, this is going to be the output file where the decision variables are written to for one path for each decision variable. So let's go ahead and open that up. Here is DSS view. So we'll just go File, Open. Just checking, this is the project. Here's the DSS directory. Boom. And then sv.dss. Here is our inflow and demand. So here are those numbers. We have 12 CFS inflow and then 5 CFS demand. Next, I'm going to open up the dv.dss file, and this should be blank. That's true. But once we run the model, this DSS file should have a path for each of our three decision variables, which are the flow through C12, C23, and D24. Okay, back to WRIMS. Let's go ahead and run the model. So I'm going to go right-click on Launch, and then Run As, and then Launch File right here. If you want to look at the run configurations, you can do that just by clicking on the launch file name and then resize this. Basically, we have the main Russell file, we have the decision variable file, the state variable file, and then we're not using that, not using groundwater either. This project right here is what part A is going to be written to in our DV, our decision variable file. And then you can see the time series. It starts on October 1921 and it ends September 1922. This is in California referred to as water year 1922. So it's the last 3 months of 1921 and then the first 9 months of 1922. That's what constitutes as the 1922 water year here in California. And then the time step is going to be 1 month. Okay. All right. Now I want to go ahead and run the model. So I'll just come up to the launch file and then run as, and then click on launch file right here. Let that run. Okay, it says it took 1 second. Let me open up DSS view. Actually, there are some DSS tabs and tools here within the WRIMS IDE, and I just haven't found any documentation or instruction on how they work, to be honest. And when double clicking, it will open up my DSS view application anyway. So let's just go ahead and take a look at that data in DSS view directly. I have the db.dss file selected. I'm going to go up to View, Refresh Catalog, and boom, here are my 3 paths representing the 3 decision variables. And take note that part A says project. So whatever your actual project name is, you'll go ahead and type that in here rather than just project, which is sort of a placeholder. All right, I'm going to select all three paths and then click on the table button. And here we have our results. Here is the flow through C12, C23, and then the diversion D24. And it's just as we expected. It's the same all year round for all 12 months. There's 5 CFS diverted flow, 7 CFS continues downstream, and of course 12 is in the upstream section of that river A. So if we go back to the model, sure enough, we have 12, 5, and 7 CFS all year long. Okay, I'm going to go ahead and make a few modifications to the input just so we can see the values here change. I should probably also show the plot. So here is the plot. We have 12 CFS in the upstream segment of that river A. And then here is the 7 CFS downstream of the node of the junction, downstream of the diversion. And then here in green, D24 is the diversion flow. All right, so what would happen if we disincentivize the diversion flow? So instead of adding a positive objective function coefficient to that diversion flow, we made it negative. So I'm going to open up run, and then I'm going to open up objectives right here. We're currently giving a 100, multiplying the flow rate through the diversion by 100. What if we set it to negative 100? So that's the only thing I'm going to change. Now the linear programming routine is disincentivized from sending any flow through the diversion. However, it's still defined as a STD, standard variable, which means it can be non-negative, which basically means that this value is going to be fixed at 0. So let's see, here is the diversions. Here's where we define D24. This STD term right here means that it's non-negative. Okay, so I'm going to close that up, make sure to save that change, and then I'm going to run the program once again. So down here at launch, run as, launch file. Okay, let's go back to DSS view and then view, refresh catalog. Now let's select all the fields, all three paths, and sure enough, we have 12, 12, and 0. So now there is 0 diversion. We can also open up the plot, and basically we have 12, 12, and then 0 for the diversion. The green is the diversion, D24. I'm going to set that back to how it was. So back to RIMS, we'll go ahead and reset that objective coefficient, or weight, if you will, back to 100, and then hit save. The next modification I want to do is to change the inflow. So currently the inflow is in the state variable sv.dss. Here it is. And if I click on the table button, I see it's a constant 12 CFS for each month of the year. But say, for instance, it decreases. What would happen to the diversion as the inflow decreases? So go edit, allow editing if you can't already edit. And then let's just say 11, and then 10, 9. Each month, I'll just decrease the flow by 1 CFS and 0 for the last month. What I think is going to happen is the system will continue to divert the maximum 5 CFS through the diversion to the farm as long as it can. And then after that, it'll still continue to divert all of the flow that is possible. So basically the maximum between the demand and what is available from the inflow. All right, so save that. Okay, close. Let's go back to RIMS and then run the model with this new modified inflow. I'm going to go right click, run as, and then launch. All right, that went ahead and ran. Let's take a look at the results. Actually, I want to go to the dv.dss file. These are the decision variables again. View, refresh catalog, and let's select all and then click on the table. All right, so here is our decreasing inflow. Here's the diversion flow. It continues to be 5 CFS as long as it can. And then, like I said, it's going to be equal to either the maximum between 5 and the inflow, which is now below 5 and controlling that maximum function return. Of course, what is flowing down in river A, downstream of the junction, downstream of the diversion, is the difference between the inflow and the diversion. So if we look at this plot right here, we see in blue, this is the inflow, or the flow in the upstream part of the river. The diversion is in green. Now it's highlighted. It stays 5 CFS as long as it can be. And then, of course, the difference there is going to be red. This is the flow in the river downstream of diversion. All right, one last scenario. I'm going to stick with this kind of wild inflow of stair-stepping down 1 CFS per month. However, I'm going to swap the objective function coefficient to be negative again. So in that situation, the blue line is going to be the same, and I guess the red line is going to be right on top of the blue line again. Right. Yeah. So the green line, the diversion flow would be 0 for the entire month. That's my guess. Let's see what happens when I do that. So we're going to go back here, change this to a negative value, Control S to save. Then in the Project Explorer, I'm going to go right click, run as, launch. Okay. That ran. Back to the db.dss file, view, refresh catalog, and then let's take a look at the data. And here it is. Yep, as suspected, the diversion is 0 for the entire month. And then right here is the river flow. So the upstream segment has the same flow as the downstream segment. And then here's the plot. There's upstream segment, downstream segment, and the diversion. All right. Well, that's all I had prepared for this lesson. What we talked about in WRIMS was running the model and viewing the results, as well as modifying a few input parameters to see how the results responded.